children, these are our 13.2 notes on arithmetic and geometric sequences. This video is just going to cover arithmetic sequences, and then we'll do a second one for geometric. So let's look at these two sequences. We have 2, 5, 8, 11, 14, 17. Can you guess what the next term is? Hopefully, you said 20 because you noticed that we add 3 to get from one term to the next term, and that's consistent throughout. So 17 plus 3 is 20. When that happens, we say that a sequence has a common difference. If we look at this second sequence, right, this one here, it goes from 2 to 6 to 18 to 54 to 162. If I asked you here for the next term, hopefully you would notice that to get from one term to the next, we are always multiplying by 3. So the next term would be whatever 162 times 3 is, which is 486. So when we multiply consistently by a number to get to a next term, we have what we call as a common ratio. Now we're going to talk about arithmetic sequences, which are sequences that have a common difference. So our formal definition is that a sequence is arithmetic if we can subtract consecutive terms. So if we can take any term and subtract the term before and always get the same number. So if we can take a2 minus a1 and a3 minus a2 and a4 minus a3 and any term a sub n minus its previous term and always get the same number, which we'll call d, then that d is what we call our common difference, and our sequence is arithmetic. We can define an arithmetic sequence two ways. One is the intuitive way that any term a sub n is the term before it, a sub n minus 1, plus our common difference. Right? In that case, we would plug a number in for that common difference, but a sub n and a sub n minus 1 would stay general, right? Unknown. The second type of definition we can write is an explicit definition where we say a sub n equals a sub 1 plus n minus 1 times d, where we're going to plug numbers in for a sub 1 and for d, but leave our variables as a sub n, the value of any term, and of n, the term position. Right? I'll show you why that happens here. So here's an example. We're going to take the sequence 2, 5, 8, 11, 14, and we want to find, first of all, the common difference. So I'm going to start with a sub 2, right, with its value, which is 5, and I'm going to subtract the previous term, which is 2. And when I do that, I get 3. So following that, the question becomes, do I get the same difference when I subtract every set of consecutive terms? So do I get 3 when I take the third term, 8, and subtract the second term? Yes. Do I get 3 when I take the fourth term, 11, and subtract the third term? Yes. And I also get 3 when I subtract 14 minus 11. So those are all equal to 3. That's true. And therefore, our common difference is 3. Which means I could find the 10th term by just adding 3. So let's look at what we do. We know that the 1, 2, 3, 4, 5th term is 14. So my 5th term is 14. And I want to get to the 10th term, which means I'm going to have to come through the 6th term, the 7th term, the 8th term, the 9th term to get finally to the 10th term. Well, how am I going to get there? Well, I'm going to add 3 once to get to the next term. I'm going to add 3 another time, and another time, and then one more time. So we're going to add 3s all along the way, right? Add a 3, add another 3. So let's look. To get from the 5th to the 10th term, we're going to add 3. 1, 2, 3, 4, 5 times. And if we do that, then we get 14 plus 3 is 17, right? 17 plus 3 is 20. 20 plus 3 is 23. 23 plus 3 is 26. And 26 plus 3 is 29. So just by adding common differences, we know that our 10th term is 29. Our recursive rule, right? We have a formula for our recursive rule here, right? Here's our recursive rule. Will be that a sub n is equal to a sub n minus 1 plus our particular common difference, which in this case is 3. And then we want an explicit rule, right? And our explicit rule follows this definition. So we're going to plug into that. And we get that a sub n is equal to a sub 1. We're going to put in the value of that first term, which is 2, plus n minus 1 times our common difference, right, which we found here, is 3. So in this case, if I wanted to get to the 10th term, I would add 9 3s to get from the first term to the 10th term. We could simplify this and we would get that a sub n is equal to, right, coming in here and distributing this 3, we would get 3n plus, right, minus 3 plus our 2, which is minus 1. So that would be a simplified form. Okay, so not too bad. You do the next one, pause the video and do that, and then come back and we'll go over the answers. Okay, welcome back. So hopefully you found that the common difference is 4, that the 10th term is 42, that a recursive rule is a sub n equals a sub n minus 1 plus 4, and that an explicit rule is a sub n is equal to 6, our first term, plus n minus 1 times 4, which if we simplify, we get a sub n is equal to 4n plus 2. Good. Hope that went well. Let's take the next step. Okay, we have an alternate definition, which I'm not going to spend a lot of time with, but it basically says that a sub p, which like a sub n refers to any term, is equal to a sub q, which is any other term, plus p minus q, where these are our position numbers of our terms, not our values. So if I apply that, that would say that a sub 7, which is the value of that term, is equal to a sub 4, the value of that term, plus the difference between our position numbers times our common difference. Okay, so we could use that definition. I'm actually not going to use it here, but you might find value in using that in some of your homework problems. But I'm going to show you a different way to find the first term, a recursive and an explicit rule for an arithmetic sequence. So the fact that this says arithmetic tells me that there is a common difference, which we're going to want to find. Okay, so we're going to start with the explicit definition. So we know that our explicit definition takes the form a sub n equals a sub 1 plus n minus 1 times d. And I'm going to take this knowledge that a sub 8 is equal to 38, and I'm going to fill that in. So if a sub 8 equals 38, then I know that 38, what's the value of that term, will equal a sub 1, which I don't know, plus 8 minus 1. I'm using 8 here because 8 is the position number of the term whose value I know. times d, which I don't know. So I can simplify this, and it says that 38 is equal to a sub 1 plus 7d. Now I'm going to come in and I'm going to take this knowledge that a sub 3 equals 13, and I'm going to plug that in. So I got 13 is the value of my term, equals a sub 1 plus, and it's my position number, which in this case is 3. So 3 minus 1 times d. So to simplify, that's 13 equals a sub 1 plus 2d. And I have two linear equations with two unknowns. Say, Mrs. Key, we've done problems like this before. You're right, we have. So you know that our next step is to subtract the bottom equation from the top. So when I do that, I get 38 minus 13 is 25. I get a sub 1 minus a sub 1 is going to subtract out. And I get 7d minus 2d is equal to 5d. That's one equation with one unknown. I divide both sides by 5, and I get 25 divided by 5. I know now that d equals 5. All right, so I can come in here, and I now know the common difference. Right, I still have to find my first term and a recursive and explicit rule for my arithmetic sequence. So I'm going to come in here now, and I'm going to take the smaller of my two equations, and I'm going to plug in d. So I get 13 equals a sub 1 plus 2 times 5. Right, so that's 13 equals a sub 1 plus 10. Subtracting 10, I get a sub 1 equals 3. And that was one of the things I needed to find. So I know what a sub 1 equals. I now need to find my recursive definition. So I think we can do that. We get a sub n equals a sub n minus 1 plus our common difference, which here is 5. And now for our explicit definition, we get a sub n equals a sub 1, which is 3, plus n minus 1 times our common difference, which is 5. Right? And you can just leave it like that, or you can simplify it. So, right, it's kind of like taking points that you know that are on a line, plugging them into point slope form, and then subtracting, solving by linear combination. So here's one for you to do. If you will pause the video and do that, I'll give you the answers in just a minute so you can check it. Okay, here we go. So in doing this, you should have started with 44 equals a sub 1 plus 10 minus 1 times d, and then 20 equals a sub 1 plus 4 minus 1 times d. Right? So simplifying, subtracting, solving, you should have gotten that d is equal to 4. Plugging that back into one of the equations and solving for a sub 1, you should have gotten that a sub 1 is equal to 8, which means your recursive definition would be a sub n equals a sub n minus 1 plus 4. And your explicit definition, a sub n is equal to a sub 1, which is 8, plus n minus 1 times your common difference, which is 4. So that's it for today. You've got some homework problems to do, and then we'll check in tomorrow. Let me know if you have any questions.